This is the key to the Module 6 and 7 review, and I wanted to put this at the beginning so that you knew approximately what time in the video that each of the problems was covered, so you could just skip to that problem. This is the key to the Module 6 and 7 assessment review. So remember, we will have Chapter 6 on this test as well. And there was just one learning target, which was learning target 27. I can determine if a relationship is a function or not. So that's what we're going to start out with. So remember, in order to be a function, every input has to have only one output. So for number 1, we've got a set of points here. So remember, x is always our input and y is our output. And so we need to make sure that every input only has one output. So since 1 is only listed once, its only output is 2. 2 is only listed once, so its only output is 4. And 3 is only listed once, so its only output is 6. So this is a function because each input, which is 3 different values, only has one output. So we're going to say yes, because each input has only one output, or you can say exactly one output. And so remember back to the pop machines. This is how we learned about the functions. Okay, for number 2, same idea. The inputs will always be on the left, and we'll label them too, but these are the inputs and these are the outputs. So we want to make sure that each input has only one output. So we see that 2 has an output of 21 and 25, and 8 has an output of just 30. So since 2 has two different outputs, they're not the same thing, then this one is not a function. So not a function, because an input has more than one output. Now remember, it's okay if an output is shared. So if we had a situation where it was 2, 8, and we had 7 as the only output, and they both went to 7, that's okay. Inputs can share outputs, but one input cannot go to 2 different outputs. So this one's not a function because an input has more than one output. Okay, number 3, we've got to make sure every input has one output. So 100 maps to 50, 200 maps to 100, and 300 maps to 150. So each of these inputs has only one output. So it is a function. And yeah, we do need to say it again. So yes, because each input has exactly one output. And number 4, we're trying to see if this is a function. This is just a line, so we want to make sure that every input has one output. So like if your input's 0, it only goes to negative 4. If your input's 1, it only goes, here, which is negative 3 and a little bit. 2 goes down to a little under negative 2. 3 goes to about negative 1.5. So it looks like every input has only one output. And if you remember that we talked about the vertical line test, we can draw a vertical line anywhere and make sure it only hits that line once. So if I draw a bunch of vertical lines together, we can see it's only intersecting that line once. So the vertical line test shows that there's not multiple outputs per input. So we're going to have the same answer. So yes, because each input has exactly one output. I'll say only this time, only one output. And so that'll be it for Chapter 6 and function or not function type of problems. Now we will move on to solving equations. So learning target 28, I can solve equations in one variable. So we're just going to solve these and check them. So you always want to make sure you check your answer to get that 4. All right, number 5, we have negative 7 times x is equal to negative 42. So this is just a one-step problem. We want to undo multiplication, so we're going to divide. And what is x being multiplied by? negative 7. So we're going to divide by negative 7. So remember that negative 7 divided by negative 7 is just 1. So we're left with 1x, or just x on the left side, because they canceled out. We expected that to happen. And then negative 42 divided by negative 7. Negative divided by negative is a positive. And 42 divided by 7 is 6. So x equals 6 is our answer. We do want to check it to make sure that we are correct. And remember, a lot of times these simpler one-step ones seem silly to check, but we're going to check them anyway. So we want to make sure this is true, and you would need to use a calculator just to make sure you're not making mistakes with negatives. So negative 7 times 6 is negative 42, and that's equal to negative 42, so that checks out. Next is problem 6. 3m plus 17 is equal to negative 85. So remember, we want to get the term with the variable by itself. So there's two terms on this side. I want to get the 3m by itself. So don't worry about getting rid of the 3 yet, but just 3m by itself. So I've got this plus 17, so I want to undo that. So we're going to subtract 17 from both sides, because that causes the 17 to cancel out on the left side, or zero out. And we are left with just 3m on the left side is equal to, now be careful here, negative 85 minus 17. So you've got a negative number, you're taking away some more, so it's like you're adding and keeping the sign. Again, using a calculator will help. Just make sure you're not doing minus a negative 17. It's just negative 85 minus 17, which is negative 102. And then your final step, now we can get rid of the 3, because it's 3 times m. So we want to undo that by dividing by 3. And 3m divided by 3 is just m, and negative 102 divided by 3 is going to be a negative number, and it's negative 34. So box that up. And we do want to check it. This one's multi-step, so we definitely want to check this to make sure we didn't make some errors. So 3, and then we said that m was equal to negative 34. So 3 times negative 34 plus 17, is that really equal to negative 85? So make sure you follow order of operations. So you're going to do 3 times negative 34 first. Positive times a negative gives us a negative, so it's negative 102 plus 17. Is that really equal to negative 85? And if you plug that in on the calculator, again, use that to your advantage to make sure you're not making mistakes. You do get negative 85. So we confirmed that our answer is correct. On the next page, we'll solve some more. Number 7, 9x plus 96 equals 15x. So this time we have two terms with the variable, so variables on each side. So we want to get them together. So since this side has only one term, leave it alone. You don't want to have one side of your equal sign have nothing on it. So we want to leave that alone. And since this is a like term with 15x, we want to get rid of 9x to get it with the other like term. So we want to get this to become 0. So we're going to subtract 9x from both sides. That causes the 9x on the left side to 0 out. And we're left with just 96 on the left side, equal to 15x minus 9x is equal to 6x. And I have a lot of people forgetting to write x. It's very, very important that you do, because saying that negative 9 is not the same thing as negative 9x. So you have to write the x there. All right, and we can combine them because they were like terms. They both had an x in there. Now we're left with something that's easy to solve. It's just a one-step equation now. So we have 96 is equal to 6x, so that's really 6 times x. So to get rid of the 6, we're going to divide each side by 6. 6x divided by 6 is x, and then we need to do 96 divided by 6, which is 16. So we got x equals 16, and we want to check that answer, especially when you have variables on both sides, because now we have two places to plug in our variable. So 9 times our x, which we're saying is 16, plus 96, is that really equal to 15 times our x, which is 16? So we want to check to make sure we are correct. So 9 times 16 on the left side will give us 144 plus 96. Is that really equal to? We got to do 15 times 16 on the right side, which we get 240. And then on the left side, we need to keep going. We need to see what 144 plus 96 is, and that is also 240. So we showed that each side was equal when x is equal to 16. So our answer is correct. And just make sure when you're checking, you don't need to, like over here we subtracted to both sides, you don't do that when you're checking. You just evaluate the left side separately from the right side, see if you end up with the same thing. All right, number 8. We've got variables on both sides and just constant terms or just regular numbers on both sides. So there are 4 different ways you can start this problem depending on what you want to deal with first. So if you do not do the same steps that I do, that's okay as long as you end up with the same answer and all your steps were valid. So I like to deal with my variables first, so I'm going to do that. But basically for this problem, we want one side with just terms with variables equal to the other side just has constant terms or just the plain old numbers together. So we have 2 terms on each side. So you get to pick which side you want your variables on and what side you want everything else on. I'm going to deal with my variables first, so I'm going to go ahead and get rid of this negative 2p because I know that that will make my variables positive, and I have a positive 7p over here. So if I add 2p to both sides, make sure you keep track of your equal sign. Remember I used the line to help you keep track of that and make sure you're doing everything to both sides, not just one side. But the negative 2p plus 2p will zero out on the right side, and we are left with just 45 on the right side. And then on the left side, combine like terms only. So we can combine 7p and 2p because they both are like terms and have the p there. So that's 9p, and we still have this minus 27, so we still need to write that. And remember, in the very beginning of the problem, we couldn't combine these because they're not like terms, and we could not combine these because they were not like terms. Okay, now we have all the variables together, so leave that term alone. We don't need to do anything with it. This side only has one term, so don't do anything with it. We want to leave it there. And since this is just a constant term or just a term with numbers, we want to get the other constant term or term with numbers on the same side. So we want to get rid of the minus 27 by adding 27. So we have to do that to both sides. And that makes the minus 27 on the left side zero out, leaving us with just 9p on the left side. And then on the right side, you need to add together 45 and 27, and you get 72. Now again, we're back to a one-step problem. To undo multiplication, since it's 9 times p, we're going to divide each side by 9, and we get p is equal to 8. Again, checking our answer for this multi-step problem is very helpful because we had a lot going on. So let's check this. So plug in our answer, 8, anytime you see a p, because that's what we're saying. P has to be 8 in order for this equation to be true. So 7 times 8, which was p, minus 27, is that really equal to negative 2 times our p, which we're saying is 8 plus 45. So just evaluate on both sides. So we're just going to keep this side on this side, this side on this side. Follow order of operations. So we have to do 7 times 8 first, which is 56. Minus 27. Is that really equal to, on the right side, we're going to do negative 2 times 8, which is negative 16. We have to add 45. So then on the left side, if you do 56 minus 27, get 29. And then if you do negative 16 plus 45 on the right side, you also get a positive 29. So we know our answer is correct. Okay, now we're moving on to dealing with fractions and decimals. So learning target 30, I can solve linear equations with non-integer coefficients. So that's all we've had so far is nice integers to work with. So on number 9, remember that when we're solving these types of problems, you want to look at the denominators because that's what's causing us issues. So we have a denominator of 2, 4, and 4. So you want to look for their least common multiple, and then if we multiply by the least common multiple, it will get rid of all the fractions. So the least common multiple of 2 and 4 is 4. So that's the number that 2 and 4 both divide evenly in 2, and it's the smallest one. Technically, any multiple will work, so you could actually multiply by 8 and be fine, but we want the least one because then we just deal with smaller numbers. So what you have to do for this problem is, remember, I'm going to rewrite it. And you need to put parentheses on both sides so that we remember to use the distributive property. So parentheses around both sides, because we need to multiply 4 by everything in both sides, not just the terms that have fractions. You have to multiply it by everything. So if you put the 4 there, and now we're going to distribute. So we have to do 4 times 1/2 x. So I'm going to write it out as 4 over 1 times 1 over 2x. Now I have to do plus, because there's a plus sign here. 4 over 1, and again I'm writing it as a fraction since I'm multiplying it by a fraction. So 4 over 1 times 5/4 equal to, on the right side, 4 times 3/4 x. So 4 over 1 times 3/4 x minus this time, because I have subtraction sign there. And then this time, since it's just 2 integers being multiplied, I'm not going to write 4 as a fraction. I'm just going to write 4 times 4. Okay, now we can start multiplying. I like to cross reduce, but if you don't like to, you can totally just multiply across like you do with fractions. So I'll show you both ways here. So for 4 times 1/2, remember you do numerator times numerator. So 4 times 1 is 4. And then for the denominator, it's denominator times denominator. So your denominator is 2. Then 4 over 2 is 2. So this becomes 2x. Don't forget about your x. But I like to cross reduce, so divide by 2 is 2, divide by 2 is 1, and then you just have 2 times 1 over 1 times 1. And since our denominator is 1, we know our answer is going to be an integer, so 2 times 1 is 2. On this one, it's pretty easy to just cross reduce here, divide by 4, divide by 4. So again, our denominator is 1, so it's an integer, and it's just 1 times 5, which is 5. But if you want to multiply off to the side, do numerator times numerator. 4 times 5 is 20. Over your denominator is 1 times 4, which is 4. And then again, 20 divided by 4 gives us the 5 that I had already written here. All right, equal to, same thing on the other side. Cross reducing here. Divide by 4 is 1, divide by 4 is 1. If you want to multiply, 4 times 3 in the numerator gives you 12. 1 times 4 in the denominator gives you 4. And 12 divided by 4 is 3. So this gives us 3, and then don't forget your x, 3x. Minus, the last one's easy. 4 times 4 is 16, so minus 16. Now we're down to a problem that has all integers. So by multiplying by the least common denominator, or least common multiple of the denominators, which was 4, we got rid of all those fractions, and now we're back to something that's more familiar and easier to solve. So let's get the variables together. And again, this one is like the last problem, number 8, where you have 4 different ways you can start this problem. So if you don't do it exactly the same way I do it, that's okay. I'm going to go ahead and subtract 2x from both sides because I know that'll keep my variables positive, because the 2x minus 2x zeroes out on the left side, and I'll just be left with 5. And then on the right side, we can combine these two like terms. So 3x minus 2x is just a 1x, or x, and then I have minus 16 still. If I would have subtracted 3x, I would have had a negative 1x over here, and it would cause me to have an extra step in the end. Now I have one term with a variable, so leave it alone. The left side only has one term, so leave it alone, and get the rest of the constant terms over to the left side. So we want to add 16 to both sides in order to zero out the 16 on the right, negative 16 on the right side, leaving us with x on the right side is equal to, on the left side, 5 plus 16 is 21. Now we want to check that. So you have to plug it into the very original problem. You cannot plug it in here because we might have made a mistake from the original problem to here. So it always, always, always has to be the very original problem that you are checking in. So we want to do 1/2 times our x, which we're saying is 21. And I'm going to go ahead and write it as 21 over 1 since I'm multiplying it by a fraction. Plus 5/4, is that really equal to 3/4 times our x again, which we're saying is 21 over 1 minus 4. So on the left side, 21 over 2. So it's 1 times 21 gives us 21. And then 2 times 1 gives us 2. So it's 21 halves plus 5/4. Is that really equal to over here, 3 times 20? And the reason I couldn't cross cancel over here, by the way. Here I can't either. So I just have to multiply the fractions. So 3 times 21 gives me 63 over 4. So since I have a fraction here, you can actually convert this one to decimals because it's not too bad. But I'm going to go ahead and keep it in fractions. So since this is fourths, I'm going to go ahead and change this to fourths. So 4 over 1 is equal to what over 4? So we're trying to get an equivalent fraction that's equal to 4. So to get from 1 to 4, we would times by 4. So we need to multiply 4 times 4, which is 16. So that's minus 16/4. So these two are equal, 16/4 and 4. And that just allows us to combine those fractions and simplify it. So let's go ahead and finish that right side. So since they're both fourths, we can subtract their numerators. So we do 63 minus 16, which is 47. So 47/4 on the right side. On the left side, I'll go ahead and change this guy into fourths. So we're just going to do another equivalent fraction. So 21 halves is equal to how many fourths? So to get from 2 to 4, we times by 2. So we have to multiply 21 by 2 as well. So it's 42. So 42/4 is the same thing as 21 halves. I did that so that I could add it to 5/4. Now that they have a common denominator, I can add their numerators. 42 plus 5 is 47. So 47/4 is equal to 47/4, so our answer is correct. And again, on this one, since there's no repeating decimals or whatnot, you could have dealt with decimals when you checked. All right, let's go to our decimal one now. So this one has decimals, not as fractions, but they're written as decimals. So in this one, we look for the least place value and we multiply by a power of 10 in order to make these all integers. So I have a tenths place and a hundredths, a tenths, tenths, hundredths, tenths, hundredths. So the least place value is the hundredths place. So I'm going to multiply by 100. Again, you want to put both sides in parentheses so that you remember to use the distributive property, because when you multiply each side by 100, you have to do it to both sides in every single term. So I'm going to write it out. We need to multiply 100 by 0.35g. We need to multiply 100 by 0.5, so 100 times 0.5. And there's a plus sign in between because it was adding. Left side we have to multiply, or the right side, 100 times 0.18g plus, because the plus sign in the middle, 100 times 0.84. And if you remember from multiplying and dividing by 100, we're just moving the decimals. So if we're multiplying by 100, that's moving the decimal place twice. So here's the decimal, 4.35g, move it twice, 1, 2. So that becomes 35, and it's a g, so we have times g, you can't forget your variable there. Plus, for the 5, we move it twice, 1, 2. Since there's a space, we fill it with a 0, so that's plus 50. Or just look, it's 100 times a half. Half of 100 is 50. Right side, same deal. Move the decimal place twice, we get 18. So it's 18g plus 100 times 0.84. So move it twice is just 84. Now we're back to a problem that has just integers and it's going to be easier to solve. Now for these ones, when you do have decimals, it's okay if you just deal with it. If you didn't do this multiplying by 100, that's okay. You could have just dealt with the decimals. But let's try to get the variables together first. Again, if you don't do the order of the steps that I do, that's okay, because you have 4 different ways you can go here. But I'm going to choose to subtract 18g from both sides. because I know that will get my variables together. So it zeroes out 18g on the left side, and on the right side, and then on the left side, 35g minus 18g. We can subtract them because they're like terms, because they both have the g's in them, and that will give us 17g. And we still have the plus 50 on that side is equal to just 84 on the right side because of the 18g's canceling out. Now to finish solving, we have all our variables on the left side, so leave it alone. The right side only has one term, so leave it alone, and get the other type like term on the right side. So since this is just numbers or a constant term, get the other constant term over there. So I'm going to subtract 50, which will zero it out on the left side, leaving us with just 17g. And then on the right side, you have to do 84 minus 50, which is 34. And then our final step is to get rid of the multiplication. So this is 17 times g. So we divide by 17, and we get g is equal to 2. Now we need to check our answer. Again, it has to go in the very original, not this one that we multiplied by and got some nice integers. So plugging it into the very original, wherever we see a g, we're going to put 2. So 0.35 times 2 plus 0.5, is that really equal to 0.18 times 2 plus 0.84? Left side, 0.35 times 2. If you can't do that in your head, then you can use a calculator, but it's 0.7 plus 0.5. And then the right side, 0.18 times 2 is 0.36 plus 0.84. And then you can add those together. 0.7 plus 0.5 is 1.2. And then on the right side, if you do 0.36 plus 0.84, that is also 1.2. So our answer is correct. Next, we're going to solve some problems with the distributive property. Okay, for problem 11, we've got some parentheses here. So when we have that, we want to deal with those first. And there's no fractions or anything that we want to get rid of, so we definitely are going to deal with those parentheses first. So we need to distribute because this is 2 times everything inside here. So we have to do 2 times y, which is 2y, and 2 times 7, which is 14. And we still have the plus 4 on the outside, so plus 4 is equal to 5y minus 3. Now notice, because we had that plus 4 on the outside, now we have 2 like terms on the same side, so we can combine them. So we have a positive 14 because we look to the left, and a positive 4, we look to the left for the sign, and we want to just combine them. So it's going to be 2y plus 18, there's a total of 18 ones on the left side, is equal to 5y minus 3. Now again, we're back to something that's familiar. We have 4 ways we can do this problem to start this problem and then finish. So if you don't do it the same exact way I do, that is okay. I'm going to subtract 2y from both sides. Actually, I'm going to do this one differently. I'm going to subtract 5y from both sides, even though I know it's going to make my variables negative, but that's okay. But the 5y minus 5y will zero out on the right side, leaving us with only negative 3 on that right side. On the left side, combine like terms, so 2y minus 5y is a negative 3y, and I still have plus 18 on the left side. Now that I have all my terms with variables on the left side, we want everything else to go on the right side. And we don't want to mess with this minus 3 because it's the only term on the right side, so just leave it alone. So I'm going to subtract 18 from both sides, and that will zero out the 18 on the left side. And then on the right side, we've got negative 3 minus 18 is negative 21 equal to, on the left side, we were left with negative 3y. So now we've got, to get rid of the multiplication, because it's negative 3 times y, now we can divide since we have one term with a variable. So since it's multiplication, we undo by dividing, but since it's a negative number, we have to divide by a negative number. So please don't forget that. So negative 3y divided by negative 3 leaves us with just positive 1y, or y. And then negative 21 divided by negative 3 is a positive 7. So again, using a calculator to check to make sure you're dealing with negatives properly is always a good idea. Now we want to check it. If I don't leave you enough room, you can always use a separate piece of paper. But for this one, we're going to plug it into the very original. So we have got 2y, so 2, and then in parentheses, our y, which we said was 7, plus 7, close the parenthesis, plus 4 on the outside. Is that really equal to 5 times my y, which is 7, minus 3? So now that we are just evaluating, we do not need to use the distributive property here, because we can actually do 7 plus 7. Back here in the original problem, we couldn't do y plus 7 because we didn't know what y was equal to. Now we're saying y has to equal 7, so we can actually do that in parentheses first. So I'm going to keep the 2 on the outside, and just remember that this operation here is multiplication, so don't forget we have to multiply by 2. So 2 times, we can go ahead and simplify 7 plus 7 to be 14, and then plus 4. Is that really equal to, on the right side, order of operations, we got to multiply first. 5 times 7 gives us 35. We still have to subtract 3. Left side now, we're going to multiply here. So 2 times 14 gives me 28, plus 4 equal to 35 minus 3 is 32. And then finish up on the left side, 28 plus 4 is also 32. So we know our answer is correct. Next one, we've got something a little extra here we need to be careful of, which is this minus right here. So you want to treat this as a negative 4. So we want to distribute first. So since we've got the 4 on the outside, we need to distribute the 4. But since it's subtracting 4, you need to treat that as a negative 4. So we are distributing a negative 4 here. So we have the 12 on the outside. Then we have negative 4 times x, which is just negative 4x. So we say we're going to subtract 4x. Then negative 4 times 2 is negative 8. So we're subtracting 8, equal to 2x minus 20. Now notice on the left side we have 3 terms, and 2 of them are like terms. We've got a positive 12 and a negative 8. So be careful here because this is a positive 12, and this minus sign applies to the 4x. So ignore this, and then this negative sign applies to the 8. So we've got a positive 12 and a negative 8. They are on the same side, so we're not like adding 8 to both sides or anything. We're just combining 2 like terms. So I'm going to put the line down just for our equal sign. So we can combine these 2 like terms. A positive 12 and a negative 8 combine to be a positive 4. And it doesn't really matter the order you put it in. I'm going to write it as negative 4x plus 4. But just be careful that you remember that this 4x is actually negative. So this simplifies to be negative 4x plus 4 equal to 2x minus 20. Again, we're back to a multi-step problem here, and we've got 4 directions we can go. I'm going to choose I'll do something different this time. I'll deal with my numbers first. So I'm going to add 20 to both sides. And that allows me to zero out the negative 20 on the right side, leaving me with just 2x on the right side is equal to negative 4x, and I'm combining like terms. 20 and 4 are both just numbers, so that gives me positive 24. Now, we are left with just 2x on the right side, so leave it alone because it's the only term on the right side. On the left side, 24 is the only term that is just numbers, just a constant term, so leave it alone. And we want to get negative 4x over here to get it with the other term with the variable. So we're leaving this one alone since it's the only one on that side. So we need to zero out this negative 4x by adding 4x to both sides. And then on the left side, the negative 4x plus 4x zeroes out, leaving us with only 24 on the left side. And then on the right side, we're combining those like terms. 2x plus 4x gives us 6x. Divide each side by 6 for our final step, and x is equal to 4. So now we want to check that answer as well. So be careful when we check here. So check into the very original, not after you distributed. So it's 12 minus, because that original one had minus 4, and then our x, which we're saying is 4, plus 2. Is that really equal to 2 times 4 minus 20? On the left side, we're going to keep that 12 there, so 12 minus 4, and we're doing what's in the parentheses first. Again, we don't need to distribute like we did in the original problem because we actually know both numbers here. This one we didn't know what x was at first. So do what's inside parentheses, which is 4 plus 2. That gives us 6. Is that really equal to, on the right side, we can go ahead and multiply. So 2 times 4 gives us 8, and we still have to subtract 20. All right, very careful here. We cannot do this first. We cannot do 12 minus 4 because that's not 4. It's 4 times 6. Order of operations says you have to do multiplication first. Remember, up here is multiplication. Down here it's still multiplication. So we have to do this first. So again, we're copying down the 12 minus, and we need to do whatever 4 times 6 is, which is 24. So it's really 12 minus 24. On the right side, we can do 8 minus 20, which is a negative 12. And then on the left side, 12 minus 24 is also a negative 12. So our answer is correct. So you need to be really careful when you have situations like this, and remember order of operations. So if you have something attached to it, it's multiplication, you have to do that first before you can subtract it from that number in front. One more with the distributive property that has a fraction in it. So I showed you a couple different ways to deal with this, but I'll just do one way. So I want to get rid of this 3 in the denominator because that's what's causing me issues and causing me to have fractions. The 4 doesn't matter. We want to focus on the denominator, which is 3. So what can I multiply by to get rid of this 3 in the denominator? And that number is 3. So we're going to multiply each side by 3. Now notice this is like one big term since it's really multiplication. It's 4/3 times something in parentheses, so I don't really even care what's in there. Same thing on this side. This is like one big term, 2 times the stuff in parentheses. So I can just write the 3 over 1 just right there, and I'm going to write 3 times 2, just stick it right there. So now it's like we have 3 things being multiplied. 3 times 4/3 times this business in parentheses. 3 times 2 times this business in parentheses. So since it's all multiplication, we can do it in any order that we want. So I'm going to go ahead and multiply the 3 and the 4/3. And that's pretty easy to multiply. If you want to multiply across, just like normal, 3 times 4 is 12, and then the denominator, 1 times 3 is 3. 12 divided by 3 gives us 4. So now it's 4 that we're distributing to the k minus 6. Not 4/3, but just 4. And you can also do cross-canceling to multiply. So divide by 3 is 1, divide by 3 is 1. Your denominator is 1, which means the answer is an integer, and 1 times 4 gives us 4. On the right side, it's a little easier. We don't have to deal with fractions. We just do 3 times 2, which is 6. And now it's 6 that we are distributing to k minus 4. Okay, now notice we don't have any fractions we have to deal with because we multiplied by that 3. So now we just have integers that we can distribute. So let's do it. 4 times k gives us 4k. 4 times 6 gives us 24, but we're subtracting it. So it's minus 24 is equal to. Then we want to distribute 6 times k gives us 6k. And 6 times a negative 4 is negative 24, so we're subtracting 24. Now let's try to get our variables together. I'm going to go ahead and subtract 6k from both sides. Again, there's 4 different ways you can go about this, so you don't have to do it the same way I do. But we're going to combine like terms on the left side. So 4k minus 6k is a negative 2k. We still have that minus 24 is equal to, these zeroed out, and then we were left with a negative 24. So be careful. Don't forget about that negative sign. So negative 24. Now that I have all my terms with variables on one side, leave it alone. This side only has one term, leave it alone, and get rid of this. So we want to add 24 to zero out the 24 on the left side. To do that to the other side too. So it zeroes out on the left side, leaving us with negative 2k is equal to negative 24 plus 24. That also zeroes out. However, since it's the only thing on that side, we have to write a number there, which is 0. We did not have to write 0 on the left side because we had something else that was there. We could have just written the negative 2k. But on the right side, we want to write our 0. Now, we want to get rid of the multiplication. So negative 2 times k, so we want to divide by negative 2 to both sides. And that leaves us with just k is equal to, because negative 2k divided by negative 2 is just k, 0 divided by negative 2 is just 0. 0 divided by anything is 0. So we can have k equal to 0 or a variable equal to 0. That's a number. And it makes it really easy to check too. So we're going to check this answer into the very original with the fractions. So 4/3, and then in parentheses, our k we're saying is equal to 0. So 0 minus 6, is that really equal to 2? And then our k, which is 0, minus 4. So be careful here. We got to do what's in parentheses first because we don't need to distribute because we know what the two numbers are. So 0 minus 6 is negative 6. And don't forget, we're multiplying that by 4/3. Multiplying. Is that really equal to, again, we're multiplying by 2 there. And we need to do 0 minus 4, which is negative 4. So it's going to be 2 times negative 4 on the right side, which is negative 8. On the left side, let's write negative 6 over 1, or negative 6 as negative 6 over 1 so we can multiply the fractions. Let's go ahead and multiply across. 4 times negative 6, our numerator is negative 24, over our denominator, 3 times 1 is 3. And then negative 24, divided by 3 is negative 8. So negative 8 equals negative 8. Our answer is correct. Okay, last part here. We want to look at solving equations with infinite solutions or no solution. So remember, no solution is an answer. We can say that a problem has no solution, but if it has infinite solutions, the actual answer is all real numbers. So just be careful with that. So number 14, we see some parentheses and no fractions, so we're going to go ahead and distribute first. So 3 times 2x gives us 6x. 3 times negative 5 gives us negative 15. Then we still have that minus 3 on the outside is equal to negative 18 plus 6x. So I always want you to be careful when you're solving these because on the test we're not going to tell you that, oh, hey, this one has no solution or all real numbers. It's just going to be all together. So be careful when you're looking at and trying to conclude early that the problem is no solution or all real numbers. Just be really careful. So I see I do have a 6x, a positive 6x on the left side, a positive 6x on the right side. So I know this is no solution or infinite solutions. So on the left side, let's combine like terms. Be very careful. I have people mess this up all the time. Negative 15 minus 3. That gives us negative 18 and 6x because these are both negative numbers. We're combining them on the same side. So 6x minus 18 equal to negative 18 plus 6x. Let's try to get the variables together by subtracting 6x from both sides. And that zeroes out on both sides since we had the same amount on each side. We get negative 18 is equal to negative 18. Since that's always true, our answer is all real numbers. If you put infinite solutions, you're not getting a 4 because that's not the answer. That's how many answers there are. So all real numbers is our answer. You do not have to use fancy math notation, but if you want to, we can do our fancy math notation too. And remember that just means x contains a set of real numbers. Next one, same thing. We've got some parentheses on both sides this time. No fractions, so we can just distribute. 4 times 3x gives us 12x. 4 times negative 1 gives us negative 4. And we still have that positive 2 on the outside. Equal to 6 times 2x gives us 12x. 6 times negative 1 gives us negative 6. And we still have a plus 2 on the outside. So I want you to be careful because a lot of you might think that, oh, hey, there's 12x. There's 12x. There's a minus 1 and the 2, so this is all real numbers. Not so much. Because here we're multiplying 4 by negative 1. Here is 6 times negative 1. So please be careful. Do not try to conclude that it's all real numbers or no solution too early. So now we've got like terms on both sides to combine. We've got negative 4 plus 2, because this is a negative 4. You can't do 4 plus 2 and then stick a negative on it. It's negative 4 plus a positive 2 is negative 2. So 12x minus 2 is equal to 12x. Same thing over here. It's a negative 6 and a positive 2 combined give us a negative 4. I forgot my x. Try to get the variables together. Subtract 12x from both sides. And it zeroes out on both sides. And so on the left side we get a negative 2. And on the right side we're left with just a negative 4 because the variables canceled out on both sides. So since that is not a true statement, negative 2 does not equal negative 4, our answer is that there is none, so it's no solution. Again, if you want to use fancy math notation, you can also say empty brackets, which is an empty set, or a 0 with a slash through it, but you do not have to. And yes, right here you could stop. You could say, hey, I know the variable is going to cancel out. This is the same. This is not. No solution. I would not do it at the beginning. I might not even do it here. So just make sure that you are confident, whether it's no solution, all real numbers, or it actually does have an answer. And with both of these problems, you can't really check. No solution you can't check other than going back over your work. All real numbers, if you check a couple numbers and they work, then you're probably right. All right, let's make up some. So number 16, create a problem that uses the distributive property and has no solution. So all you have to do is pick a number, 5. All right, in parentheses, make sure there's a variable in there, x plus 1, say. So I know that that actually is equal to, if I distribute, 5x plus 5. If I want no solution, the right side cannot equal 5x plus 5. So let's make it equal 5x plus 6. It has to have the same number of variables, otherwise they won't cancel out. So really, the only thing you need to change is that constant term. So I know that this has no solution. Okay, on the right side, fill in the blanks so this equation has infinitely many solutions. So you want to run through this to make sure that you fill in the proper number. So negative 7 times x would give us negative 7x. Be careful here. Negative 7 times negative 2 gives us a positive 14. And we have that plus 3 on the outside. And those two are going to combine to be 17. So on the left side we get negative 7x plus 17. And so since we want infinitely many solutions, we need the exact same thing on the right side. Look, I already got my negative 7x. So I need 17. So that number is going to be 17. That makes it infinite solutions. So the actual answer is all real numbers, but it has infinitely many solutions. Okay, one story problem, then we'll be done here. So Josie works part-time at a restaurant and gets paid $7.50 an hour, plus $50 in tips. Her friend Alan works part-time at a different restaurant and gets paid $9.75 an hour, plus $23 in tips. Write and solve an equation to find out how many hours they need to work until they will have earned the same amount of money. So we don't know how many hours they need to work, so that's our variable. Let x equal number of hours. And then for Josie, we know to figure out how much money she makes, it's $7.50 per hour. So $7.50 times x, because she gets $7.50 each hour, plus an additional $50 in tips. And then we know Alan is $9.75 x, because it's $9.75 per hour, so you have to multiply them, plus only $23 in tips. So since they don't make the same amount per hour, we know this is not no solution or all real numbers, because she makes less per hour but more in tips, he makes more per hour but less in tips. So if we want to know when they're equal, remember we just set them equal, and then we can just solve that. We do have decimals in this problem, but we don't have to multiply by 100. If you want to, you can. I'm choosing not to, since it's only two numbers that have those decimals. So let's get the variables together. So I'm going to subtract 750x from both sides, 7.5x. That zeroes out on the left side, leaving me with just 50 on the left side is equal to 975 minus 750, $9.75 minus $7.50. Combine those together, since they're like terms, is 225x, and we still have plus 23. Now we want to subtract 23 from both sides to get that term with the x by itself. 23 minus 23 zeroes out. 50 minus 23 is 27. is equal to 2.25x. I'm going to rewrite it over here. And our final step, since it's 2.25 times x, we want to divide by 2.25. So we have to divide each side by 2.25. And that gives us just 1x on the left side, or on the right side, and on the left side we get 12. So remember, we need to interpret what that means. Well, x was number of hours, so it's 12 hours. So they both have to work 12 hours in order to make the same amount of money. Now, how much money is that? So if we check our answer, that actually will tell us how much money, or if we just run it through either of theirs, it'll tell us how much money. So let's just run it through both to make sure that we're right as well. So is $7.50 an hour times 12 hours plus $50 the same as $9.75 for 12 hours plus 23? So $7.50 times 12, Josie makes $90 just from working, and then $50 in tips is a total of $140. And then Alan, if he makes $9.75 per hour and works 12 hours, so multiplying these two, he makes $117 from just working, and then $23 in tips. Add that together, you get $140. So we know our answer is correct, and they earn $140 in 12 hours for each of them. And the last question is, you want a part-time job. Would you rather work at Josie's restaurant or the one that Alan works at? So you can easily do this. We're saying you want to work 15 hours each week. So you can easily do this by plugging in 15 to each. Or you can think about it this way. You know that at 12 hours, they've earned the same amount of money. Okay? After 12 hours, they both have made $140. So if you keep working more hours from this 12 hours, every additional hour you work, Alan makes $9.75 more, while Josie only makes $7.50 more. So if you work more than 12 hours, you would rather work at Alan's job, because we know that they both have made $140 after 12 hours, and each additional hour we know that Alan's actually getting paid more. So if you want to make more money, you're working 3 more hours. $9.75 times 3 added on to this is more than only $7.50 times 3 added on to $140. Okay, that's it. So let me know if you have any questions and be ready for your test.